Joanne. So
There you go.
yep. So I'd like to go ahead and get started. We are noon. Welcome everybody, and you've already made me co-host, have you not,
I have.
Joanne? So I can share my screen. I'm going to go ahead and do that as we speak. Make sure this works. And here we are. So what I'd like, and let me just make a couple adjustments here. What I'd like is some feedback. Joanne, do you think everyone can see my screen okay? Are we okay there?
I can see it, and it is the full screen. So,
And
and there's some things popping up in chat. People are saying, yeah, they can see it.
awesome, guys. Well, look, let me tell you how this works. We have a very short hour of presentation here, and frankly, a guy like me cannot do a topic like this justice in an hour. So, if you have any questions, comments, concerns, or anything with an automotive slant you'd like to talk about, throw them in the chat room. And as far as the chat goes, it might be best if I answer a lot of questions at the very end of the program. But if there's something that seems important, just yell at Joanne on the chat and say, hey, man, interrupt him. This is an important question. And I don't have any problems with that. I never have. So that's the unprofessional side of what we're going to do here. But as you're all coming in, starting the presentation here, guys, this is a topic on targeting mechanical diagnostics with pressure transducers. Now, as a little bit of introduction to myself, many of you know me. I'm Adam Robertson. I work with CarQuest Technical Institute and part of DiagNation, which is a technical support company. We do technical support and programming during the day. I have put a link to our website. If you have a cell phone, you've got basically a QR code that you can take a picture of there. I have my email address on the screen, adam@diagnation.com. I know many of you have been students of mine in the past. You may have a different email that has become corrupted with advertisements. So if you could please take a note of the adam@diagnation.com, be an easier way to get a hold of me. And for those of you who like what you see in the 1 hour we have to speak right here, I am doing a longer version of this class at ATE Seattle. ATE Seattle, if you're not signed up, although I don't know where we're at sign up wise, coming up March 22nd through the 24th of this year at the Doubletree Hotel, like it does every year. And I'll be teaching a few different classes, but I'll be teaching this particular topic on Saturday afternoon. So if you have any more interest in that, please get a hold of somebody, get a hold of myself. Once again, email address on the screen with that. Let's get cranking. Look, when it comes to pressure, pressure can only do one of three things. Pressure can either go up, go down, or remain the same. Now you need to think about this because a lot of us technicians, especially when we're starting to learn lab scopes, for example, we like to do that comparison. We like to compare known good to our presumed good or bad, but we always have that want, that need, desire as a technician to compare our reading to somebody else's. And I got to agree that in some cases that works well. For example, if you're trying to look at, say, cam crank synchronization like that, that sort of thing is great to compare known good to ours. However, when it comes to many other waveforms and a little bit beyond the scope, pardon the pun, of this class, um, there's a lot of hiccups in that way of learning lab scopes. But I can tell you from our topic today, with the basics of pressure and vacuum, or if you just want to say pressure, because really that's all it is, from that topic, it really needs to be understood that comparing known good to yours really isn't going to work. But to try to keep things simple, what I tell everybody is this: it's like, guys, pressure really can only do one of those three things. It can either go up, it can go down, or remain the same. So if that's true, then all we as technicians need is a few things to properly analyze these as it relates to, in this case, and this class, engine operation. And what I'm speaking about here is number one, you got to have the proper equipment and the knowledge to go with that to measure the change. You've got to be able to measure it and understand what you see. You are also going to have some way to determine location or timing. For example, I put on the screen where the piston is, where the valve location is, whether that's intake valves, exhaust valves. Are we at bottom dead center with the piston? Are we top dead center of the piston? We need to have those abilities. And of course, especially using laptop style lab scopes, we have a lot of software to help us with that. And of course, that's something, if you guys have questions, we can certainly talk about that at another time. And you should have already written down my email address. And I'll make sure, actually, guys, if you're hanging out in chat, maybe Joanne or Brenda, if you could once again put my contact email in the chat box, it's adam@diagnation.com. I can cover those questions as they come up further down the road. But, and then of all this being said, if pressure can only do one of three things, then we have to measure it, know where our timing's at, and then it's simple. I need to understand what that pressure is supposed to do. Gosh, am I expecting that pressure to go up? Am I expecting that pressure to go down? Am I expecting it to remain the same? And with that, let's wind into this. So the first thing of approach that I have here for you is to answer the question, well, what is a pressure transducer? Well, a pressure transducer is going to be a component, I'll show you some pictures here later, that converts physical quantity into an electrical signal, or to say that we have measured a pressure and we can relate it to a voltage that we can see on our scope. All right. Now, if you take nothing else out of this class, I would like you to pay attention to these next few slides I'm going to put on the screen. They are critically important, and I'm going to follow them up with one, maybe a couple case studies, depending on how our time goes. But this is truly important to understand. And what I'm getting at here is the question I have on the screen: what can a pressure transducer test and why? For example, I have what I'm going to refer to as an absolute pressure transducer. I'll explain that a little bit later, given the time. I have an absolute pressure transducer plugged into the exhaust of this car. I am not looking at back pressure. I am not looking at catalyst efficiency. I am not looking at emissions. I'm not doing any of that. What I'm looking at is I'm looking at the expanded gas during combustion that comes out the tailpipe. And one of the ways I describe this action is if you think about the 4 cycles of an engine, when that piston comes up on the compression stroke and it compresses our mixture, when it fires, it's the expanding gas that shoves that piston down. And the instant as that piston is going down, that expanded gas creeps out that exhaust valve. When that exhaust valve opens to let it out, there's a burst of expanded gas, or say a volume of expanded gas that goes into the tailpipe. All right. Now, as that expanded gas goes into the tailpipe, we now have this component to measure that pulse. But I want you to think about something. And frankly, using the term exhaust pulses is a good way to do this. But think about a 4-cylinder engine like this Kia, which we'll get to later, that I have this plugged into the pipe. This Kia has 4 cylinders. All right. Every time a cylinder fires, there's going to be a mass or a volume of expanded gas that comes out the tailpipe. But the tailpipe isn't a smooth action. The tailpipe isn't constantly running that exhaust that we see when it's cold. It's actually a series of these pulses. It's the 1 3 4 2 1 3 4 2. But one of the things to consider here is what happens in between those pulses. So if I have a firing order of 1 3 4 2 and cylinder 1 fires and the expanded gas comes down the exhaust, there's going to be a period between the cylinder 1 and the 3 that atmospheric pressure is going to go back into the exhaust. So basically what we have is we have pulse, atmospheric pressure, pulse, atmospheric pressure, pulse. So 1 3 4 2 1 3 4 2 1 3 4 2, and in between is that little suction, if you will, of atmospheric pressure pushing back in. Now, some of us in the past, including myself, have worked for maybe one of the people that got us on our path to this, where they maybe hung a napkin behind the tailpipe, or they hung a dollar bill behind the tailpipe to watch the flutter of it, and they could tell you that dollar bill, that napkin, if it sucked back into the exhaust, we had a misfire. Well, now what's nice about technology and what I'm talking about here is that we can take this and we can measure it and draw a picture of it on our scope screen so we can see that event rather than just the flutter of the napkin. So what do we use pressure transducers for? Exhaust pulsing. What else do we use it for? This is great. And some of you that practice with your lab scope might have not even thought about this test. Once again, I'm using the same Kia here because we're going to use this as our case study. But I have my absolute pressure transducer, my WPS 500X. If you follow the hose, you will see that I have it plugged into the fuel pressure regulator vacuum port. So what I've done is I pulled the vacuum hose off of the fuel pressure regulator, and my pressure transducer is physically plugged into that port. I want you to think about this. What would I be measuring with that crazy kind of setup with my pressure transducer? And the answer is that although every one of my injectors may go click, 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 I may hear them click. Does a clicking injector verify that it dropped hydraulic pressure? Does it verify that when it opened, that fuel came out? And the answer is no, Adam. They can click and nothing can come out. But what we know is with the accuracy of the test equipment we have available to us today and the resolution of the scopes that we have today, I know that simply inside this diaphragm, I've got the diaphragm here in the spring. I know that the hydraulic pressure in this line, every time an injector clicks, opens, and delivers fuel, I know that there's going to be a vibration created inside that diaphragm. And by measuring that and syncing to the engine, like I spoke about when we started, I can see that not only did injectors click, not only did they fire, but I can tell you if they delivered fuel. Now that's spectacular on some engines, depending on, it's spectacular depending on whether we have injectors that say are under an intake manifold, or we've got someone out there we need to mute, guys. If you could take care of that. I've been trying yeah, please make sure you guys are muted up. Thank you. But at any rate, guys, I can actually see each injector open and deliver fuel and vibrate that. That's another place I use pressure transducers. Another place I use them. Well, you're like, well, Adam, that looks very Honda-ish. It's a Honda. But what I have here is I have now hooked my absolute, there's that word again, which we'll get to. I've hooked up my absolute pressure transducer hydraulically to the fuel rail. Now, yes, it's true. At the end of this fuel rail, there is a vacuum operated pressure regulator that I could be measuring the pulses inside the regulator to see if fuel was dropped. But in this case, I'm doing something a little different. I've hooked in like I would with a standard fuel pressure gauge. I pulled out the banjo bolt, I put my adapter in, and I've got my absolute pressure transducer hooked to the fuel rail as I would with a fuel pressure gauge. Now, in this case, which is pretty cool, in this case right here, what I have is the ability, after I burp the air out of the system, I have the ability to not only read the pressure, so say the pressure is 50 pounds or whatever, but I know that with the right pressure transducer of an absolute setting, I know that I can adjust that tool and I can zoom in. And once again, I can see not just the fuel pressure, but I can see the vibrations created every time an injector turns on, clicks, and delivers fuel. So now you should be sitting there going, wow, Adam. So you're saying if I go back to this picture that I could see fuel drop by measuring the vibrations in the fuel pressure regulator? Yes. I can measure fuel drop by the hydraulic vibration? Yes. Before some of you get carried away, let me clarify something. I have done a lot of this style testing over the years. And I will tell you that for those of you who think that this test is going to be accurate enough to determine if an injector is lightly low on flow or not, it simply is not. That is still a situation where the injectors would need to be pulled out and test physically on test bench. But I can tell you in my experience that if I've got an injector that's plugged or 50% plugged, which I mean substantially plugged, yeah, in many cases I can pick that out. But the reality of it, okay, is that if I'm plugged in hydraulically to this end of the fuel rail, and let's call this cylinders 1, then 2, then 3, then 4, I can tell you just from the nature of the beast that I'm going to see more drop from cylinder 1, and it's going to get less and less and less as the fuel rail gets further and further away from my pressure transducer. And these are things that you would start to figure out as you start practicing with this test. And frankly, this is a great test to practice with because most of you within the sound of my voice have put a fuel pressure gauge on a car. This is absolutely no different hookup wise. Use this instead of your mechanical fuel pressure gauge so you get the pressure and the vibrations, not only from the injectors opening up and dumping fuel, but you also get the vibrations from the fuel pump. Let's move on. Look at another one. Guys, this is just another picture. This happens to be a 3-liter Nissan. I am now using a Delta pressure transducer. Hang on for a second.
Adam, there's a question in chat.
Yeah, shoot, go ahead.
Do you prefer the WPS 500 rather than the Delta for this test?
Yes and no. And guys, if you hang out with me, that will be answered. And if for some reason, Joanna, if that does not get answered by the end of the class, please ask that again. But I'm going to show you a straight up comparison between the two. And then you can make your own decisions off of that. But my answer is I use whatever I grab first. How's that for an answer? All right. That could be argued with. But continuing on with this, in this case, I'm using a Delta pressure transducer and measuring, once again, the pulses inside the fuel pressure regulator right here. Just a different engine, a little different hookup, but I've gone from absolute pressure sensor to Delta, and that was a great time for that question. Let's move on. Here, I've now installed a Delta pressure transducer in the exhaust, once again, measuring those pulses. In this case right here, and I'm going to assume some of you guys can see the unit in my hand as I hold it up. The unit that you see in the exhaust right here is one of the first edition designs of what Automotive Test Solutions refers to as an exhaust amplifier. All right. It's beyond the scope of this class to go too deep into this, but I will give you my Adam's opinion on this. I have this. It has a very unique Venturi design, similar to a carburetor, that will concentrate and, for the lack of a better term, filter the exhaust pulses to make them a little bit easier to interpret on the lab scope. Now, for those of you who really want to dive into things like intake manifold waveforms and especially exhaust waveforms, I will tell you that once you move above 6 cylinders, some 6 cylinders are tough, but when you go from some of the 6 cylinders into the 8 cylinders, by the way, the 10 and 12 don't count. We'll leave those out because they're different. But some 6 cylinders and most V8s, this unit or a unit similar to it really cleans up those exhaust pulses. And gosh, guys, if you have questions about that, once again, beyond the scope of my single hour I have with you here, you can certainly get a hold of me at the email address that should be in the chat room for you. Let's move on. And then, of course, a lot of guys, when they first start doing pressure transducer diagnostics, they go, gee, Adam, I want to do in-cylinder. I want to take a pressure transducer and I want to take a compression hose, pull the spark plug out, stick this in, hook it up, and read all the pressure changes in the cylinder. No doubt, wicked cool diagnostics, wicked cool. And here we go again, another class all in itself. Guys, I could teach a pressure transducer class on just what you see on the screen and take a week to get across to you the things we've learned in the quarter century we've been practicing with this, okay? But there is another use for a pressure transducer. Now, here is a picture. I just threw it in. By the way, couldn't figure out, it's from Idaho. But here's a picture of me using a Delta pressure transducer in the exhaust of a twin exhaust car. Now, there's been a lot of talk in the Facebook pages and some of the other diagnostic pages out there about how you look at exhaust pulses when you have dual exhaust. And look, to keep it as simple as possible, I've been pretty successful with this. I basically took my smoke machine cone, plugged it off, and I read my pulses here. All right. Now, once again, take some practice, but there's another option for you. Now, this is one of the pressure transducer testings that I am becoming more and more confident with, or I should say, I'm liking it more and more. And actually, I'll go as far as to say, if you've ever called me on the phone, if you've ever called through DiagNation and we've talked diagnostically, or if we've talked on the side, or if you've been in any of my classes, I will tell you that if you guys are practiced in doing relative cranking compression, I now recommend in many, many, many situations that during a cranking relative compression test, you add a pressure transducer to the crankcase. Now, on this Subaru, you can see I pulled the dipstick out. It's up here on the right. And I've simply plugged my hose into the dipstick tube for the crankcase. Okay. Now, in this case, I'm using an absolute pressure transducer, but yes, I could certainly use my delta or pulse sensor also, really doesn't matter. But I have become more and more comfortable with this and found more and more problems. I will literally show you one in just a couple minutes here. But there's another use for my pressure transducer. And gosh, how could we talk pressure transducer and not throw in the basic one that many of us started with all the way back in the early days of the Allen scope and the Sun scopes and all of that, intake manifold pressure. But in this case, with our lab scopes and a high quality transducer, and more than the transducer, because by the way, it can be delta or absolute. I'm showing you absolute in this picture, but with good quality software to run with your lab scope, we can tell an immense amount about the mechanical integrity of the engine by monitoring not just overall engine vacuum, but how each one of the individual cylinders breathes from a volumetric efficiency standpoint. So, once again, incredible test with a lot more detail to be seen later. Here you're just looking at another picture. As a matter of fact, with the WPS 500, these lines come with the standard kit. I've literally just screwed it right onto the 7/16 Schrader port on this 5.4 Triton. And with that screwed on, once again, I'm getting the pulses. However, I will tell you, in a V engine configuration where I'm plugged into this rail, but we know on the other side of the engine is another rail, there will usually be a massive difference in amplitude from one rail to the other. Because, as I mentioned before, from a pressure standpoint, you're going to read fuel pressure. That's not a problem. But the individual pulses per cylinder are going to typically decrease the further you get away from the transducer. In this case, heck, the other rail's on the other side of the engine. But, guys, this is a good topic for a one-on-one when you deal with one of these. I have collected several known good and many bad waveforms of this nature, and I've learned kind of the key to breaking those down to figure out what's going on. So if you're looking at that and you want to know more, gosh, you'll have to get a hold of me. Let's move on. And then a new one to hit our industry over the last few years. I'm starting to see this one creep up in more and more of the chat rooms that are out there. Utilizing my pressure transducer, as you see here, absolute in this case, hooked right into my radiator pressure testing cap. So I just pulled the little bulb off of it, plugged it in. Now I'm reading hydraulic pressure in the cooling system. Now think about this one. Now I know it's hard to see the lap scope that I have on my computer right here, but you'll see if you look closely, I have also synchronized to a firing event. So I have a firing event and I have a pulse in the radiator. What this is showing is it's helping me to synchronize if I have pressure building in the radiator due to, say, a head gasket, as an example. I may be able to see that, predict what cylinder it is, without really taking anything apart. Now, I'm going to warn all of you, there's far more to what you see in the pressure. For example, the blue stuff, if you can see my cursor on your screen, all these pulses right here were happening in the radiator. But this particular Subaru, it was a volcano, man. It had a wasted head gasket. But boy, have I got a lot of wicked cool waveforms where this is paid off. All right. So this is just another one of those things that's going to require some practice on known good cars. But here's a wicked one for you. So when I first started with this years and years and years ago, I started hooking my lab scope up. I'd be on the road teaching, and I'd go to every shop that I could reasonably within my travel. And I was hooking my lab scope up to the radiators and looking at a lot of different cars. And what I was hoping to find, I was hoping to find a vehicle that had that very elusive, I lose a quart of coolant a month kind of problem. Reality of it was, guys, I never found it, nor with my testing do I believe you can be that accurate. But what I did find was a couple things. A, I have lots that I can show you with blown head gaskets. Okay, that's a given. But I found something very unique. Most of you within the sound of my voice have probably done this. You filled up a cooling system, all right? And then you rev the engine up, the coolant level goes down, you top it off, then you jam the cap on. There's no doubt in my mind some of you do that. There's nothing wrong with it. I do it too. But when you rev the engine up, the water pump became more active and it drew down that water level, put a little bit of pressure in the block. So you got that extra cup or quart, whatever coolant in it. But here's what I found, and this was freaking cool, and it was by accident. So I noticed that when I had my pressure transducer hooked up to the radiator, like you see right here, the cooling system, if I rev the engine up and let it off, and rev the engine up and let it off, provided it has a belt-driven water pump, obviously, then I would see what looked like a cam sensor. It would have a positive pulse, negative pulse, positive pulse, negative pulse. So it would go through this positive, negative, positive, negative, positive, negative as it sucked a little bit and pushed back out and sucked a little bit. And I'm like, wow, I'm seeing my water pump work. That's kind of cool. But then I got the chance to test a car. It was probably a BMW or an Audi. I don't remember at this point. But the water pump impeller had fallen off the water pump. And many of you listening to me have been through this, all right? I was revving the engine up and I didn't see that camshaft waveform from the coolant. It didn't change. I'm like, this is kind of weird. They go, yeah, that thing's here because it overheats. And I'm revving it up and I'm like, whoa, I think I found an easy way to see if the water pump impeller's working. And sure enough, the water pump impeller had fallen off. Therefore, when you did the snappies, you didn't see the positive, negative, positive, negative, positive, negative. Found completely on accident, but it was an extra thing to throw with this style testing. And man, was that cool to me, you know? So I would like to share with you as we dive a little deeper into this program, literally, guys, a case study. Pete, if you could mute your mic, that would be fantastic. And Gary, I noticed you guys. So Pete and Gary, both of you could mute those. I heard a little bit of background there. At any rate, guys, this literally happened this week, and this is awesome. So none of you have even had the chance to see this yet because this was a DiagNation case study I did. I've got a 2012 LML Duramax 6.6. According to our customer, the shop, good friend of mine, he goes, Adam, he goes, this customer really screwed this truck up. It overheated and they drove it to the point that it stalled. Now, can I help you guys all out with something? You should not, A, overheat a vehicle, and B, if you overheat the vehicle, driving it to the point that it stalls is very, very bad. But when we got a chance to look at this, he goes, Adam, he goes, I think this engine's junk. It has at least blown head gaskets. And I'm like, ah, man, you know, we don't always get the real story, the complete story from the customer. So the story we get is, wow, he thinks it overheated and stalled, but we really don't know what happened. I mean, honestly, guys, granted, this one smelt burnt up, but I'm like, okay, so what things do you think we should look at without wasting a lot of diagnostic time to figure out maybe if we should tear this engine apart and try to fix it, or if this thing's a boat anchor? And I said, you know, diagnostically, let's do this test. Now watch. You'll see already that we have two absolute pressure transducers. I have one pressure transducer going into the degas bottle, overflow tank, whatever you want to call it. And you'll notice we've got it hooked up by simply using that smoke machine cone. This pressure transducer is going to measure the pressure in the cooling system. This pressure transducer here is hooked to the dipstick tube or the crankcase. Hard to see, but I have another channel shooting over here that I have hooked to the signal for one of the injectors for a sink. Okay, that's going to be for sink operation here. Right here is my high amp current probe on my starter cable. Now I want you all to just stop and think. Adam, it looks like you're going to do a cranking relative compression test with the high amp probe. Yes. You're going to look at a sync of one of the injectors for counting purposes. Yes. You're going to look at the pressure, the point of this class, in the degas bottle to see what the cooling system does. Yes. And you're going to look at the pressure in the crankcase to see crankcase pressure. Yep. We're going to do all of that at once. And here are just some of the neatest results I have ever seen. And guys, this was literally this week. I'm like, yeah, what a story this tells. First of all, as you guys are looking at this picture on your screen, as you're trying to assimilate what you're looking at, on the lower left-hand side of the screen, I have marked every channel of what the test was. For example, A in blue is the relative cranking compression right here. Relative cranking compression, amperage to the starter. Channel B in red is the pressure waveform from my crankcase in red. In purple is the injector current to my piezoelectric injector. After all, guys, this is an LML Duramax, okay? But without going into how the piezoelectric injector works, just take this spike right here and realize, and let's just call it cylinder 1 for the lack of knowing. If that's the number 1 firing of the injector with current, that is the next firing, the next. So between this injector and this injector, we've done a whole 720 degrees of crankshaft revolution. We've done 2 crank revolutions. By the way, guys, for those of you not familiar with pico, down here in the bottom of the left, you'll see there's an S for seconds. Over here, you see 12. From this point here to this point here is 12 seconds, guys, and it continues to the edge of the screen. So this is quite a bit of cranking we've got going on. But biggest point here, guys, each one of these purples is 720 degrees. Boom, 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 boom. Okay. The last one, which you may or may not be able to see depending on your computer at home, is the cooling system pressure. In brown is my cooling system pressure. Now, let's analyze not even 5 minutes worth of hooking up our scope, but picking the right things to hook to, looking at the diagnostic value of what's on the screen. So I begin cranking it. My starter has the rush-in current that easily broke 1,000 amps, by the way, and then it goes into relative compression. Hey, look, guys, this ain't a tall drink of water, but between here and here, I only have like, I don't know, 3 cylinders with something resembling compression. Geez, guys, this is not a relative cranking compression class. That's not what this is. But let me tell you something. If I have an 8-cylinder engine, all right, and I crank it over, and I'm just looking at the current to the starter every time I'm rolling it over, then every cylinder that comes up to a compression stroke should have a burst of current. And relatively speaking, the current should be the same for every cylinder. So realistically, guys, between this point here and this point here, I should have had 8 very similar pulses. Well, come on, man. I've got nothing even close to this. This engine only has compression on a couple, all right? But here's the real value. Oh, no. Guys, here's the real value. I think every one of you, honestly, within the sound of my voice, could probably crank this engine over and go, dude, it's junk, man. This thing is going to sound horrible. But where did the horrible go? If I have a lack of compression, which I definitely see in all of these pulses, by hooking to the cooling system and the crankcase, if I get reaction out of those, it gives me an idea where it went. For example, in just 12 seconds of cranking, my cooling system went up, 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 up. Look at all those pulses. I love this. Walk, 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 walk. It hit 4 PSI in 12 seconds of cranking. Can I help you guys out with something? No cooling system should hit 4 pounds of pressure by simply cranking it for 12. So we definitely know, and by the way, the smell test would have showed this, but we definitely know that we have pulses of pressure in our radiator, our cooling system. And if you lined everything up, you will see, although it requires some discussion, but you will see that when we have low compression, there is a correlation between the positive pulses in our cooling system and the low compression cylinders. Well, come on, guys. That indicates we could call it a head gasket leak or a cracked head or something. But one of the more significant things to notice in this picture is what the crankcase was doing. And if you look between a firing event and another firing event, once again, this isn't starting, it's cranking, you'll see that there is a rhythm. Guys, there is a rhythm. Pump, 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 wah. Pump, 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 wah. Pump, 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 wah. There is a rhythmic pumping of pressure into the crankcase, hitting approximately 2 pounds of pressure. So what's significant about pressure analysis is, once again, you compare this to any other waveform, the details aren't going to be there. You have to understand pressure can only do one of three things: go up, go down, or remain the same. You have to have a way to measure it. Hey, we're measuring it with a couple transducers. You have to have a way to time it. We're timing it with our injector. We have all of the factors necessary to determine what's going on in this engine. And so what we're able to see is not only is it filling the cooling system with pressure, it's filling the crankcase with pressure at times, relieving it, filling it, filling it, filling it, relieving it. So guys, here's a question to all of you. What's the likelihood that head gaskets are going to fix this engine? Or what's the likelihood a new set of heads is going to fix this engine? Because I can give you Adam's opinion on this. Adam's opinion is this thing's a freaking trinket. And I believe just off of these results, we're going to have some pretty spectacular low-end damage also, as far as cylinder seal is concerned, rings are concerned. All right. My point here, and I love talking about this waveform in this class because I literally diagnosed this week. It's an incredible waveform that we had the chance to take all the dynamics and put them together. And in literally 5 or 10 minutes of collecting waveforms here, we have a very, very nice complete diagnostic on this car. Instead of the technician that writes, motor is junk. I don't want motor is junk. I know it's junk. I want motor is, okay, someone's going to say it. So before you get your hair on fire, Adam, it's not a motor, it's an engine. Motors are electric cars. I got it. So back to what I was saying. This motor is not only junk, it is pressurizing the cooling system and the crankcase, and only has this. The whole story is complete on the screen. Just chew on that. I just think that's awesome. All right, let's move on. So Joanna, a little bit earlier, the question came up about, well, Adam, what pressure transducer do you prefer to do, say, a fuel pressure regulator test or an intake test? And the question was, do you prefer absolute or delta? Well, let me show you guys the difference here. Now, don't take this as a sales pitch. I'm not holding or showing pictures of every system that's out there. We have a lot of choices out in the field when it comes to these. Of course, I have my opinions, and you're more than welcome to email me to get me my opinions. But here's what we have. The absolute design pressure transducer is going to be a pressure transducer that measures, absolute pressure. Well, what do you mean absolute? Well, let's just call it actual pressure. This thing is going to read me if it's 20 psi. Depending on the transducer, it may read me if it's negative 10 psi or 20 inches of vacuum. But this type of transducer is going to read actual pressure in a value. The one thing to understand about absolute pressure transducers is that they're going to have to be powered by some source. For example, the WPS 500 I have on the screen right here is powered via a rechargeable battery and USB cable. You can kind of see right there on the screen the input. There's a lot more to understand about the settings and everything. Once again, questions for a different class. But this has a rechargeable battery. Some of them have replaceable 9-volt batteries like the Fluke PV350 series. There's others like the Automotive Test Solutions, as an example, that have a proprietary and dedicated external power supply that power them. Any way you look at it, there will be a power supply regarded to make this work. All right. So here's just a few pictures. Here's some Automotive Test Solutions many of which can be found through many, many manufacturers like this. Once again, require external power source. Here is the Pressure Pro. This is a kit that Automotive Test Solutions puts together that allows you to use the proprietary power interface. That's right. This box, through these cables, powers these up so they work, and then you can run this into any lab scope. So instead of being stuck in this case to having these transducers as an example only for the Automotive Test Solution scope, Bernie and the boys put together this kit so we can hook it up to our Picos, our Snap-ons, or Autels. Look, any questions about this, before you guys buy something, just call me. We can talk about it. We have kits from, say, Dytex overseas. We've got the crummy kit. We have the better kit. We have stuff from, we got stuff from Handtech. We have stuff from Rotkey. Definitely worth the discussion, but my point is, lots of them exist. So, everything I just showed you were absolute pressure transducers that had to have a power source, and they physically put out a voltage representative of actual pressure. Then we move into the next style, all right? For example, I've got a homemade one right here in my hand. I have several homemade versions. And any of you that are interested in what makes these tick on the inside, we can talk about it. But when we come to delta pressure transducers, most of them operate off the idea of a piezoelectric device. For example, if you want to think about a knock sensor in a vehicle, a knock sensor, when the chip is vibrated or compressed and released properly, a voltage is produced. See, these sensors don't require a power source. These sensors produce a waveform based off of pressure change. If the pressure goes up, they produce voltage. If the pressure goes down, they produce voltage. Notice I didn't tell you positive or negative voltage. That's dependent on the wiring in the sensor. But the key here with a delta pressure transducer is that they will change based off of pressure change. If there's no pressure change, these will not produce any voltage. Okay. And then you can see what I put on the screen. I said the output now is relative to pressure changes. Let's do a little demonstration here. And hopefully, Joanna, I hope this helps to answer the question earlier, because this is probably one of the best demonstrations that I have played with, performed, and shown. And of course, the picture I'm using here, and I've got to give some credit, Brandon Steckler actually put this together, and I promptly stole it from him and told him I was stealing it because he did the work on this. But it's a beautiful representation of the difference between an absolute pressure transducer on the left and a delta pressure transducer on the right. So what we've done here is we've got a common hose coming into a T. I've got my absolute and I have my delta. All right, here's what we've done. I want you to think about this. I've got a pressure transducer, all right. On the top is absolute, on the bottom is delta. Both of them start at 0 volts. All right, Adam, we're at 0. The first thing I did is I put it into a vacuum. So picture me taking this, sucking on this hose, and putting a vacuum against this. The absolute transducer dropped, but the number it's reading is the actual vacuum pressure. We'll just call it 10 inches of vacuum for the lack of a better term. It measures the actual vacuum. My delta dropped in voltage, but the representative value is not necessarily, without a lot of calculation and time, the actual value. But see, I don't really care about the value. I just want to say, hey, look, did it react? Did the delta react? You bet. Did the absolute react? Yes. But what I did is when I sucked in on this hose, I quickly put my thumb over the top to block it. I put my thumb over, so now we're holding vacuum. Yeah, it slipped a little bit, but I'm still holding vacuum in that hose. And the absolute pressure transducer reads that there's still vacuum in that hose. Absolutely. All right. My delta, on the other hand, went back up to 0. Now, the thing to understand about this is the delta pressure transducer went back to 0 because there's no change. That hose, this hose right here, may still have vacuum in it, but it's not changing. Therefore, the Delta said, nothing. But this one read the vacuum. But interestingly enough, at this point right here, guys, what did I do? At this point, I released it. When I released it, we saw the absolute transducer tell us the truth and go back to 0. But our delta changed because pressure changed. Okay. Now, while I'm at 0, and while I'm at 0, there's no change. Now, I took that hose and I put pressure into it. I blew pressure into the hose. We see absolute go up and tell me, Adam, you have 2.5 inches of pressure in this. Okay. There's your pressure, and I'm holding it. The delta did a bounce, but came back down to 0. It came back down to 0. Why? It came back down to 0 because even though there's pressure held in the hose, this is still representing no change. Then I released it, the voltage dropped, and we saw a spike out of the delta. And you guys that are sitting there probably, okay, Adam, come on, get on with this, man. What does it mean in the real world? Because I knew this question had come up. I've done a demonstration for you here. All right. I have got a absolute pressure transducer and a delta pressure transducer on a 4-cylinder engine. That's right. 1342, 1342, with a firing event in the middle, looking at the exhaust pulses of this engine. All right. If you look at the delta's reaction and the absolute's reaction, or dang it, was that absolute's reaction or delta's? Guys, it really, in a point where we're just looking for pressure change, it really doesn't matter which one you use. Now, okay, before you get your hair on fire, yeah, I agree that delta pressure transducers have a more rapid state of change as compared to some, catch that, of the absolutes. But the long and short of it, for the most part, is I have reaction on my delta, I have reaction on my absolute, or vice versa. Heck, I even forgot, okay? But if you notice this, they're very similar in their reaction. So the question that came up, well, Adam, what do you prefer? In a lot of cases, it comes down to price. For example, this pressure transducer right here is an absolute pressure transducer, and these things run upwards of $2,000 for the kit. I can build delta pressure transducers with the reactive component inside, the Radio Shack 273-073 piezoelectric generator. They're about $2 a piece. I can build these very cheap, but your absolutes are going to be quite a bit more money. But my point is, you're not going to use a piezoelectric pulse sensor to measure in-cylinder pressure. Nope, it won't work. You're not going to use it to measure hydraulic pressure. Nope, it won't work. You'll just blow it apart. So they have their own place and stay. The real difference is this guy will typically work anywhere that this will, but this won't work everywhere that will. And like I said, I don't want to burn up your hour here with the minors of it. I want to get on and show you in a case study. That's what we're going to finish this class up. Why all this is necessary to know. All right. So here we go. And before you say it, Adam, you're really going to bring up a 2001 Kia Sportage? I didn't know any still existed. You know, I was talking with the other members of DiagNation today, and you know, all of us get in trouble sometimes. You know, we get a car that just beats the ever living crap out of us. And I'm here to tell you guys, I don't think a 2001 Kia Sportage with a 2-liter should be a tall drink of water for you guys to diagnose. This one was. If you care, it was in Fresno, California, because I physically went out to the shop to help with this. This car started at shop number 1. The customer brought the vehicle in. I'll make this very condensed. Customer brought the vehicle in because it runs rough. Shop number 1 put plugs, wires on it, and made it considerably better. As a matter of fact, they thought it was fixed, gave it back to the customer. Customer brought it back and said, you know, it's not doing the same thing, but it's still rough. I don't like it. Well, this rough that they're talking about, And I'm stating right on the screen, very intermittent, single misfire, maybe. There's an Adam term for you at idle. The reason I say maybe is because it only happens at idle. It drives, guys, this thing drives perfect. It drives perfect. But when you pull up to a stoplight in gear and you're sitting there, every now and then there's like a bump. The whole thing goes ka-tunk. Now, I'm saying it feels like a single cylinder misfire, ka-tunk, and then everything's fine. But you need to think about something. How are you going to find a misfire that's only a ka-tunk, that little bump while you're sitting in the intersection? The customer hates the vehicle because of it. Well, frankly, they should have hated it because of what it was. Didn't want to hurt anyone's feelings. But here's the thing. When I was discussing this with shop number 2, because shop number 1 said we don't have any problems with it. When I was talking to shop number 2, and of course you can read there's no codes, normal scan tool data, no live miscounter. You guys get the idea. They put quite a few parts and pieces on. They said, Adam, we can feel it. It happens. And they explained exactly this to me. And you know what my question was, guys? And I think this is a great freaking question. Great question. My question was this. Does it misfire or doesn't it? That's a stupid damn question. What do you mean? Does it misfire or doesn't it? No, it's a very straightforward question. You told me you feel this little, like a single misfire or a bump. Is it a broken motor mount? Is it a power steering pressure problem? Is it a transmission that settles? Is this truly a misfire or is it something else? And if you wanted to hear crickets, that's exactly what I got back. They were silent. Because their answer was, Adam, now that you laid it out on the counter that maybe it isn't a little misfire we feel, maybe it's something else. Oh my gosh, because by now it's gotten plugs, wires, coils, injectors, lots of diagnostics. And when they called me, they thought this thing had a bad wiring harness. That's what they thought was wrong with this car. And I'm not denying this. I'm going, whoa, man, we're into this a little bit deep here. You know what? I know most of you guys can't talk to me because you're muted out. You can get in the chat room if you want, or maybe you're just sitting back mowing your pizza and listen. Here's the thing. What do you think I did first to this vehicle? I went down and showed up. There's the car. Ooh. You know what's kind of tough about this? This has a waste spark ignition system that's under this tube. At the end of this tube is a mass airflow sensor. I can't get to all the coils unless I pull that tube off. If I pull the tube off, the engine won't run because it needs that mass airflow sensor. All right. But at any rate, this should still be pretty simple. There's the car. There's the dash if you care. Hey, it's got almost a half a tank. That's nice. All right. But the idea behind it was this. My first test was right here. Guys, these are literally pictures from the shop as I just noted my diagnostic routine. Now, well, Adam, why did you use an absolute pressure transducer in the exhaust? Because it's what I had on me. All right. Well, why did I do this test? Does anyone want to guess why I did this test? Why did I perform this test? Do you know what I need to determine? That little bump. Is it a misfire or isn't it? Because if I can't answer the simple dang question of is it a misfire or isn't it, how am I going to diagnose this car? What am I going to do? Am I going to throw the plugs, the wires, the injectors, the wiring harness at it? Well, shit, they've already done half of that. Is that going to be my approach? No, because this is easy and I'm lazy. All right. So I plugged it in there. Let's look at the results. I have, as I circled up top, 5 pages of information. Now, guys, this is a waste spark ignition system. So on the bottom, I have synced to one of the coils. So there's true fire, waste, true fire. Waste, true, waste, true, waste, true. And in typical lab scope fashion, sometimes it's a little bit hard to make out the voltages that get described. But looking at this view, it's very easy in most cases to see the true fire, the waste, the true fire. And that is going to be cylinder 1's fire. That's the waste, and that's cylinder 1 again. So what you see in the exhaust pulses of this car is from here to here, 720 degrees, or 4 firing events. 1, 2, 3, 4. And it's consistent. You know what? Out of those 5 seconds, I got nothing. Out of those 5 seconds, I got nothing. And then it happened. You got to remember, guys, this is an intermittent problem. It's running perfect, 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 perfect. Wow, something is amiss right there. Now, I'm assuming all of you within the sound of my voice can actually see this, all right? But something happened right there. Let's blow this up and take a look. I have marked for you to help the fire, waste, fire, waste, fire. Fire, waste, fire. This is what we call an exhaust disruption. Remember about almost an hour ago now, where I talked about the exhaust going pulse, 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 pulse. So you've got the pulse, atmosphere, pulse, atmosphere, pulse, atmosphere. So however, here's what we have. Pulse, atmosphere, pulse, atmosphere, pulse, atmosphere, pulse. Huge, long atmosphere followed by a recovery of a piezoelectric delta sensor. This drop right here happens when a cylinder does not produce the same volume of compressed gases as the others. So I'm looking at this going, whoever this was, whoever that was, did not produce the same volume of compressed gas because we had a much larger, for the lack of a better term, suction event into the exhaust pipe, all right? Or atmospheric push into the exhaust pipe. Now the trick, however, is finding out who that is. First of all, if that coincides with the bump that the customer feels, I have guaranteed it's truly a misfire. I'm on it. Okay. Next thing I'm going to do is I'm going to open this up, and there are several different types of overlays out there. Once again, we could talk about that at another time. But what I have done is I've put an overlay from my number 1 firing event to my other number 1 firing event with a firing order of 1, 3, 4, 2, sync on 1. This graph I have put over the top shows me from this number 1 firing event to this number 1 firing event. It shows me the stroke that every cylinder is on. For example, number 1 is on power, exhaust, intake, compression. Number 3, compression, power, exhaust, intake. You guys get the idea. My dropout happened right here. And because I was measuring exhaust pulses, I need to know which one of cylinders 1, 3, 4, 2 had a lack of expanded gas. So as I look at this, I'm like, it wasn't 1, it wasn't 2, it wasn't 4, but dead obvious, number 3. When the number 3 exhaust event happened, there was a drop in that pressure in the exhaust. My problem is number 3. It is not number 1, number 2, 4, number 2. My problem is number 3. Guys, I am 50% of the way to my diagnostics now because at least I know, yes, it's a misfire and what cylinder it is. And I found it quick and easy. Next test. Well, I can't really get to spark, dang it, because it's under this thing. So here's the thing about pressure transducers, all right? Here's the thing about pressure transducers. Every engine is designed a little bit differently, and access is going to be different based off the engine configuration. So I have to be dynamic in what I'm going to hook to. In this case, I'm like, well, I can get to the fuel pressure regulator pretty easy. So I'm going to add a sink to my number 1 injector. I'm going to unplug the regulator and plug my pressure transducer in. Okay? Wow. So now I have exhaust pressure or exhaust pulses, fuel pressure regulator pulses, my ignition sink, and my injector sink. And whoop, all be damned. Look at that. Back here. All good, all good, all good, all good, all good, all good. Wham, I got it to do it again. That was my disruption of my exhaust. Let's blow it open. Guys, let's get something straight. Many of you know me. If I get excited over crap like this, it means I need a life. But I'm telling you, this stuff excites me. This is pretty cool. And here's what I see. I have marked everything out. I have the number one fuel injector. In blue, I have the drops per cylinder. Drop, drop. This is the disruption in the fuel pressure regulator, showing fuel click, drop, click, drop, click, drop, click, drop, click, drop. Do you notice that every time an injector was commanded on, there was a disruption in the regulator? And it goes on and 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 on. Number one injector tells me which drop this was. Number one injector, pull to ground, hold it on, blue, drop in the regulator. Number three, oh, hold on a second here. So my misfire happened here on number three. This is my number three drop for my injector. But I have to go back here to the one before that happened. And you know what? My injector drop is exactly the same from here to here, which means, oh, guys, think about this. And I'm only going to keep you for a few more minutes. Please give me just a couple more. We're almost done. If you look at the drop here, and I know that it was fine, but I still had a misfire that happens very infrequently like this. This is the real key. And guys, this is really me diagnosing the car. I'm like, wow, guys, you know what? The likelihood it's a wiring harness for injectors, out the window. Do you think it's a bad injector, Adam? Nope. I'm never 100% sure, but that's way down on my ladder. I don't think it's injector. I don't think it's the wiring to the injector. I don't think it's mechanical, because reality-wise, that just doesn't seem mechanical to me. Is it on my list? Yeah, but it's low. Frankly, with good injector control, drop, and a single cylinder misfire, I got to go look at the secondary system. Now, the problem with this car all along to look at the secondary was that you had to pull this off. But here's the clue, guys. Now that I pulled the intake off and I'm going here, I'm concentrated on going to one cylinder. Do I care about cylinder 1, 2, or 4? No. I proved that in all these waveforms. I said, look, I got to go look closely at cylinder 3. Well, there's cylinder 3 for you. Do you see that? Oh, and I know some of you are going, oh, Adam, before you even think about that, I want you to seriously look at what this car did. That is a brand new plug wire. It's run long enough that we can finally see the little snake bite coming through it. It's a brand new part, guys. And you know what new means? New means never, ever worked. All right? Here's the problem with every diagnostic that happened on this car. Well, Adam, we already put plugs in it. That's not the problem. We already put wires in, coils on it. That's not the problem. Man, you guys need to stop, go back to basics, because in a matter of minutes, with the tests I did with my pressure transducers, I literally said my problem is ignition. And when I took it apart, gosh darn it, if I didn't see something that obvious, do you realize I would have taken a magnifying glass and looked this entire thing over, looking for just the most minuscule problem, because I know it's that cylinder. All right. At any rate, guys, I'm going to bring you back on here. We are, gosh, guys, we're out of time. An hour flies by awfully, awfully fast. For those of you who are out there, you're more than welcome to turn your cameras on and your mics, as long as you don't all speak at once. But if you have questions, I would like to take some time and answer those. So I can take a look at chat room now. Let's see. I think, oh, Jeremy and Ashley. Hey, guys, that was your question for this. Nice to see you guys again. Do we have any other questions on everything that we talked about here? Any other questions? You guys are like church mice, man. It's like crickets out there. I got a handful of you, and oh, you guys all got that. All right. So just a couple things, and I'll open it back up. Guys, on your screen, I put up We have the ATE Training Expo coming up, although I'm going to have to assume, and I don't know, Joanna, that's probably close to sold out, if not sold out. But March 22nd through the 24th, I will certainly be there. I am teaching a class on this topic on Saturday afternoon. And then Gary and myself from DiagNation will be teaching a radio frequency class on Sunday, which, oh man, is it wicked cool. You've never seen anything like it. And then we're doing some network stuff together too. So we've got quite a few classes out there, and we'll have a booth out there so we can chat one-on-one in person. But back to the show at hand. Any questions out there? If you do, please just unmic and ask if you could. Boy, I'm not hearing so much.
There aren't any questions in the chat.
Yeah, I'm in the chat right now. I'm looking through. Well, yeah, Carl wants me to give Gary a big old kiss. I might give him a hug, but I don't know about the kiss, man. But Carl, nice to have you here from Kukui. I don't really see anything else going in the chat. It was
Adam, you did too well. Everybody already knows everything now. There's no questions.
Guys, it's nice to see you again. Well, all the way down in Astoria. Feels like I'm down in California, so we're a little bit further away than Seattle. But yeah, awesome. So we're going to see you at AT, right, guys?
Oh, yeah.
Of course. Of
Yeah.
course. Yeah. Well, cool. Thanks for showing up. I appreciate it. And I don't
Josh says hi too.
say that again. Oh, okay.
Josh says hi too.
Right on. Yeah, we'll have a booth. We'll have a little booth there and be able to
Nice.
chat. You know, yeah. It's a little expansion for the DiagNation team. You know, we're certainly try to do everything we can for the boys out there. So
Nice.
it was really nice to see a lot of names. I recognize a lot of names in the chat room. That was great, guys. So, any other questions out there? So let me get this straight. You guys want to get back to work instead of sit here and talk. I'll tell you what, we need more technicians that have that attitude. That's fantastic. Yeah. All right, guys. Well, with that, any other questions? Once again, my email address is adam@diagnation.com. So adam@diagnation.com. It was in the chat room. Don't be afraid to get a hold of us with any type of question, comment, concern. Otherwise, for some of you, I guess the next time I might see you is at ATE Seattle, if you guys are going to make it. So I appreciate it. And thanks for hanging out.
Adam, thank you so much.
Awesome. All right.